All right, so I just wanna,
Yeah, I didn't have one about that.
hey, all of you on Zoom,
Wait, there's only 5 questions? No.
Oh.
There's like 20.
hey, everyone on Zoom, if
Well,
you
it's
would
24.
please,
Okay, my 5 is different.
mute.
Nice. I got one. Positive relationships include which of the following?
Hey, Jackson.
My
Jackson,
bad.
no, you're not bad. It's just, you know, I don't think you want us to hear your. So if you would hit mute, that would be really awesome. Cool. Well, I mean, okay, I'm gonna pause the recording for just a second. It was so fun. Okay, we are recording again. So, what I want to say to everybody is, just a reminder, we are Zooming class tomorrow. Okay, so if you want to come here and Zoom it, go for it. I did put a note outside of that door, just reminding people. So please, again, if you want to come, cool, but you don't have to. But do come to Zoom. I'm just gonna, I'm at a meeting that starts at 7:15 tomorrow morning and it goes until 6:15 at night. So it's gonna be a real pleasure to duck out and get to talk to you about math. I'll just find like a corner where I can find some floor space and I'll sit on the floor and teach y'all. It'll be fun. So it'll be the best part of my day. Anyway, I just want to remind everybody that that the lesson, the second class activity, if you have it to hand in, please do. You can leave it right there. If you don't have it for me today, that's fine. You need to email it to me tomorrow. Okay. So I just made 2 quick announcements. Number 1, students tomorrow, or swimming class, and number 2, here's the where you can hand in your lab activity too if you're going to do that today. If not, email it to me. Yeah. Okay. Those are just really important announcements that I want to be sure that I've communicated. Any questions on anything? All right. Makendra, I like your picture.
Okay.
Oh, did someone have a question on Zoom?
Yeah, about the computer use. I know in the videos the fella showed on the TI-83 how to do a factorial really quick without going into the math one, and I missed it. I missed how he did that.
Oh, you want to see a TI-83 calculator?
If that's okay, the
Yeah.
quick way to do a factorial.
Yeah. Can I see it? Okay, give me 1 second. Thanks for asking. Someone here, I could tell you the buttons to press, but I'd rather show you. Oh, you even have a math thing in here. Cool. Okay, so you see my calculator? Or it's not my calculator, but you see this calculator?
Yes.
Cool. Okay, now I got to put on my reading glasses. There we go. I'm not getting older. Okay, so suppose we wanted to do something like, well, it doesn't matter. I'm just gonna, what's your favorite number?
4.
4. Okay, I'm gonna hit 4. And then do you see the math button right here?
Yes.
You hit math. And then what you want to do is you want to go over to this PERB. This PERB is short for probability because we're ultimately learning this so we can start computing some probabilities. So what you do is you arrow over to the PERB. And then if you look and you want to do a factorial, that's number 4. The other one you might want to be using, or you will want to use in the lesson we're talking about, is this NCR. So if I wanted to just do factorial, I would hit 4 and then I've got it. If I wanted to do like 4 choose 2, then what I would hit is 4. I would hit math. I'd go over to perb. Now I'd go here to number 3, the NCR. And then you hit 2. And there you go.
Thank you.
No, thank you for asking. I really appreciate it. Any other questions? Yeah.
So when we are differentiating between the multiplication principle and the combination principle, the big thing that we should be looking for is how many and arrange like the words to be able to use.
Yeah. So essentially, whenever you're asking how many ways something's going to be done, you're probably going to either be using the multiplication principle or you're going to be using combinations. Okay. Either one. So both of those are what we call some counting principles. But then you need to take it one step further and ask, well, how do I compute this? Do I use the multiplication principle or do I use the combinations? And what determines that is if order matters. So if the order matters, you're going to use the multiplication principle. Okay.
So when you mean that if the order matters, does that mean like no restrictions?
No, what that means is like, does the order in which you're counting things matter? So like order matters when you're talking about zip codes, right? Telephone numbers, PIN numbers. If you see the word schedule, right? Anything that you would assume that order would matter in, that's when you use the multiplication principle. Okay, essentially, when you have a collection of things and you're picking a sample, whether the sample is a sample of M&Ms or a group of people to serve on a stupid committee, then you use combinations. Okay, those are great questions, and you know this sort of thing can take a fair amount of practice. I am going to leave myself a note to show you, to bring something to your attention tomorrow when we're on Zoom. Let me actually do this. Where is it? Okay, cool. So what I want to do is pick up where we left off in class yesterday, okay? You may or may not recall, but what we had was we had a club that had 20 members. We were just narrowing it down to 2 genders. And we said that there's a total of 9 men and 11 women. And we want to choose 5 for a committee. Okay. So we played with a few different examples yesterday where one of the things we did is we wanted it to be all men. Okay. We wanted to know how many different ways we could select that committee. And then I believe we did 3 men and 2 women. And we wanted to know how many ways we could select that committee. And then I jumped into the at least 4. Okay. You may or may not recall, but I wrote down yesterday, the at least, at most, no more than, no less than. In all of those situations, you want to be open to the fact that there might and will probably be more than one possibility. In other words, that word or, okay? So you'll notice that I keep emphasizing things with words. It's to help you translate. translating from English to math is non-trivial and it takes a lot of practice. So I try to give you hints with the words. So and means multiply, or means add. Okay. So I'm just going to set this one up again because we didn't really compute it. I will say that on any test, I'm not going to have you compute really long things. The reason being, tests are timed, and I have to think about how I want you to spend your time on a test. And it's not pushing buttons on a calculator. Okay, so I'll make it very clear prior to the test what you'll need to actually compute versus what you'll just need to set up. But the online homework, you will need to compute some answers. Okay. So you may recall we wanted to know in how many ways we could pick the committee could be selected if we wanted at least 4 women on the committee. I'm overlapping from yesterday. I hope that's okay. Okay, so I wrote down some steps. The first one is to translate in the context of the question. Okay, so what do I mean by translate in the context of the question? What I mean is, what does at least 4 mean? If I have at least 4 pets at home, which is actually true, because I have an exciting life, what does that mean? I have 4 or more. Okay, so now what I'm saying is not only do we need to translate what at least means, but we need to do it in the context of the question, in the sense that how many people are we maxing out at picking? Aren't we picking just a total of 5 people? So what I would say is that's 4 women or 5 women. Okay. Any questions on translating in the context of the question? Yeah.
So if it's a lot more than 4 or 5, so it's like 30, you still write it out like this.
Yeah, and then you would hopefully be like, Lauren, you are the biggest pain in the rear for asking us to do this much work. Yes, please be thinking that. So that leads to a very good question. If ever you're working out a test question and it's so long and involved, you're not doing it correct. I have to make an answer key and I don't want anything long and involved. Okay. So yeah, I mean, if we were picking a total of 30 people, that means 4 or 5 or 6 or 7 or 8 or 9 or 10. Yeah, and then you should get kind of upset at me. Yes. Okay. Now, the next step that I wrote down yesterday is account for the entire sample. Okay. We've now translated what at least 4 means. But now we have to think about, well, we're choosing a total of 5. So we've got to account for all 5 of those people. Tell me, if there are only 2 genders in this group and 4 of them are women, what do I know? There's 1 man. You got it. And if there's 5 women, how many men are there? None. Notice each of these add up to the total number of people that I'm choosing. Okay, so what I'm saying is 4 women and 1 man, or 5 women and no men. How many women do we have to choose from? How many total women are there? 11. And how many do we want in this first possibility? 4. How many total men do we have to choose from? 9. And how many do we want here? 1. Notice I multiply because of the and. What do I put for the or? Plus. Good job. And again, your top numbers are not going to change because now we're looking at the number of ways to pick a committee that consists of these folks. In other words, we have a total of 11 women. We want to choose 5. We have a total of 9 men and we don't want any of them. No offense. Now, honestly, on a test, I would probably just let this be. On the online homework, you're going to need to compute this. Okay. Now, how you write it on a test, I don't care if you write it this way, if you write it 11 NCR 4 times 9 NCR 1. I'm not, you know, any of the notation that I show you, you can use. Or you can even write it as a combination 11-4, combination 9-1, combination 11-5, combination 9-0. The reason why I want to show it to you like this is if you notice that the top numbers add up to the same thing. They add up to your total. And your bottom numbers also have to add up to your total sample size. Okay, you with me? So combination C is the same thing as choose, yes. So if you're going to put this in your calculator, the way that you would enter it is just put parentheses around each of these things. So literally you can enter it as one long strand. Watch, I'm going to enter it just like this. So it's 11, get to NCR, however your calculator does it, 4 times, and then use parentheses 9, NCR 1, close parentheses, plus, now do these in parentheses, 11, NCR 5, times 9 NCR 0. Technically, you don't need to compute 9 choose 0 because there's only one way to choose none of the men. One way, don't choose them. And so you should get 3,432. All right, so we did all this yesterday other than the computation. What I want to do is just one more example here and then, yes. It would be more than one term. In other words, things separated by or. No, no. No, that's one of the splendid things about mathematics. There's just clarity is a beautiful thing for me. Okay, now suppose we want, when I say prepare for more than one possibility, notice there were 2 possible ways we could satisfy this. Sometimes there might just be one. Okay, what if I want to do same sort of thing, but now I want no more than 2 men on this committee? Well, the first thing we've got to ask ourselves is, what does no more than 2 mean? 2 or less. With me there. Okay. So if I want 2 or fewer men, doesn't that mean that I could have 0 men or 1 man or 2 men? No, you could have started with the 2 or 1 or 0, doesn't matter. Okay, now remember, we've got to account for our entire sample. If we're picking a total of 5 people and there's 0 men on my committee, what do I know? That there's got to be 5 women. If there's one man on my committee, how many women? 4. And if there's 2 men, how many women? 3. Notice we're counting up here with men and therefore we're counting down here with women. They've got to add up to 5. Do you see the patterns starting to emerge on these? All right. Well, remember, or means plus. And now we need to set up each of these. How many total men do we have to choose from? 9. And how many total women do we have to choose from? 11. Notice those top numbers don't change. And once we've translated this, that gives us our bottom numbers, right? We want 0 men and 5 women. We want 1 man and 4 women, or we want 2 men and 3 women. Cool-ish. All right. Let's get to something a little more interesting than people. Let's talk about M&Ms. I mean, I'm not saying that M&Ms are, I like chocolate. So suppose now I have a bowl and my bowl contains M&Ms. All right, so suppose my bowl has 5 green M&Ms, 3 red M&Ms, 4 yellow M&Ms, and 2 blue M&Ms. And I'm going to select a sample of 4. Now this is silly because honestly, if you knew me, you would know that I would probably take the whole bowl and dump it in my mouth at once. Like I would not just stop at a sample of 4, but anyway. Okay. So what we really want to know here, let me move this, is as follows. In how many ways? We're counting. Can this sample of 4 be selected if, how about part A? There's no restrictions. Like we're not going to be particular about the color. Okay, we're asked to count things. So the first thing we want to know is, does order matter? No, it doesn't matter. We're picking 4, we get to pop them in our mouth. Okay, order would matter here if I said, if the first one must be a red and the second one must be a green, that sort of thing. In other words, if I start distinguishing the order in which I pick them, but I would have to very specifically say that. Okay, so how many M&Ms do we have in this bowl? We got 14 of them. How many are we choosing? We're choosing 4. So you can write this as a combination of 14, 4. You can write it as 14, choose 4. And you could compute it if you really want to. There's 1,001 ways. Yes.
Did we use multiplication on this one then or no?
No. No, because if you did the multiplication principle, then you're saying order would matter. Check out how many more possibilities there would be. If order mattered, you would have 14 ways of choosing the first one, 13 the next, 12 the next, and 11 the next. Oh my gosh, 24,024 ways. So when order matters, there's just so many more possibilities. Okay, What if now I want to pick one of each color? Would you all grant me that means one green and one red and one yellow and one blue?
Can I ask a question?
Yes, of course.
I'm trying to wrap my head around this, and I'm sure it's simple, but not in my mind. That if it's restricted, like order matters, to me, it seems like it would be more limited in the solution.
No, it would be less limited here in the solution. Oh, do you mean if order matters versus doesn't?
Yes, if the order matters,
okay.
to me, it's limiting.
Let me go back. If order matters, let me take a simpler example, okay? Suppose I have, if I'm just picking 4 M&Ms, let me do, I want to pick something with smaller numbers here. When order matters, you have more possibilities. I'm going to go back to, suppose I'm giving you 3 books, okay? So suppose I have 3 books, or let me say 5 books, and I'm going to give you 3 of them. Okay? If the order in which I give you these books doesn't matter, it's going to be far fewer than if order does matter. For example, let's just pretend my books are A, B, C, D, and E. Okay? If I'm going to give you 3 of them, and order matters, then, for example, ABC is different than ACB, which is different than BAC, which is different than BCA, which is different than CAB, which is different than CBA. Do you agree if the order matters, these are all different possibilities?
Yes.
Okay, but if order doesn't matter, these are redundant. You're still walking away with the same 3 books. So once order starts mattering, you have so many possibilities because each of these is distinct. Whereas if the order in which I hand you them doesn't matter, and you're just walking away with the same 3, all 6 of these are just one possibility when order doesn't matter.
That makes sense. Thank you.
No, I think you're awesome for asking. Thank you. And by the way, nothing is simple. Things are simple once you see it, but seeing it is not simple. So please don't put pressure on yourself. These things take time to absorb. All right, so going back to this, would you grant me one of each color translates to 1 green, 1 red, 1 yellow, 1 blue? Okay, well, haven't we accounted for our sample of 4? Yep. How many green ones do we have to choose from? 5. How many are we wanting? 1. And tells me times. How many red M&Ms do we have to choose from? 3. And how many do we want? 1. And tells me times. How many yellows do we have to choose from? 4. How many do we want? 1. And how many blue ones do we have to choose from? 2. And we want 1. Notice if I wanted to add up my top numbers, it adds up to my total of 14. If I want to add up my bottom numbers, it adds up to my sample size of 4. If you care, it's 120. What if now I want in my sample of 4 exactly 3 green M&Ms? Hey, notice I don't have the at least, at most, no more than, no less than. So I don't have to think about more than one possibility yet. Okay, so what does it mean for exactly 3 green? Well, 3 green, but we now need to account for our entire sample. So what does that mean? And one other color. Notice you don't have to think about whether it's red, yellow, or blue. If you want exactly 3 green, it just means that you take the green ones and then lump the rest of them together. Okay, does that make sense? Ask me if you have a question, like, please don't not ask questions. Well, how many green M&Ms are there? 5. How many do we want? 3. And close. There's 9 other M&Ms, right? Cover up the greens. 3 plus 4 plus 2, 9. And how many do we want? 1. I know, we really want them all if we're going to get down to the facts here. If you compute that, you should get 90. Okay. Questions there? Okay, let's do this one then. Now, suppose we want at least 2 red M&Ms. All right, what do we see here? There's probably going to be an or because we have the at least. Yes. What does at least 2 mean?
2 or more.
2 or more. Yeah. Okay. Have these things written down. They take a little while to remember. Okay. So in the context of this question, since we're picking a sample of 4, tell me, what does that mean? It means 2 red or 3 red or 4 red, right? Because we're picking a sample of 4. Can we pick 4 red M&Ms? No, how come? Because there's only 3 to begin with. So when you're going through these and listing all the possibilities, you're limited. You're limited either by your sample size or you're limited by the number you had to choose from the get-go, right? If you only have 3 red M&Ms, you just can't pick 4. Does that make sense to everybody? So once you translate, you got to stop and think about it. Like, what are we limited by? And again, our limitations are either by the sample size or about the number that we had to begin with. Okay. So we've translated this. Now we need to account for the rest of our sample. How many total M&Ms are we picking in our sample? 4. So if I have 2 red M&Ms in my sample, what does that mean? I have 2 other colors. I don't care whether they're green, yellow, or blue, they just can't be red. And if there's 3 red M&Ms in my sample, how many others? 1 other. Notice how much time I'm taking in terms of translating this and writing this down. I'm not just jumping to the math, okay? I strongly suggest you take the time and do it this way. It will help. Okay? So now we can set it up mathematically. I have a total of 3 red, and how many other colors do I have? 11. Notice my top numbers are still going to add up to my total, or tells me plus, and then I have 3 and 11. Now, by taking the time and translating this, I now have the bottom numbers that I need to choose. Okay, how many red ones did we want here? 2. How many others? 2. And in this scenario, how many red ones did we want? 3. And how many others? 1. And again, I'm going to mention this check mechanism. Notice that my top numbers add up to my total of 14, and my bottom numbers add up to my total sample size. Questions on that? Okay, then how about I'm gonna do one more part here. And how about I give you all a couple minutes to set it up on your own, and then we'll go through it together. Does that sound like a good idea? Okay, so let's see, we're picking a sample of 4. So what if I want in my sample to contain no less than 3 yellow? So I want you all to take a moment to set this one up. I'll give you a couple of minutes. Give you a thumbs up when you're ready. I don't want to rush anybody, but I also don't want to give you too much time in which to fall asleep. Holy smokes, this is the largest Zoom group we've had. I guess tomorrow we'll probably max it out, or hopefully, right? All right. What does no less than 3 mean? 3 or more. Good. And in this case, it means 3 yellow or 4 yellow. Thumbs up, thumbs down. Awesome. What's my next step? Tell me what to say. Good. Okay. Notice if there's 3 yellow, we have 1 other. If there's 4 yellow, 0 other. You cool this far? Awesome. You're doing great. So now I set this up. Notice the OR tells me that I've got 2 different terms. Terms are things that are separated by plus or minus signs. Okay, what do I put up here? Four, because I have a total of 4 yellows. And then what do I put up here? 10, because there's a total of 10 others. Those numbers don't change. Now in this first sample, I wanted 3 yellow and 1 other. And in this next one, I wanted 4 yellow and no other. How do you feel? Awesome. Okay. So I want to follow up by just making a couple of quick announcements. And just give me a second. So cool, I can share my screen. So what we have now done is we have now completed lesson 3. And so I am going to assign the homework to be due a week from today. And what I'm going to do is give you activity number 3 on Friday in class. And I'll post it on Moodle on Friday. So today is the 20th. I can't really forget that one. Save changes. All right. So my final announcement that I want to make today is that lesson 2 online homework is due tonight by midnight. My hope is that you get that done because we've just now completed lesson 3. Okay, wait, I got to show you something else. You want to see something else that's cool? Because technically I have 5 minutes, but I'm not going to ramble to you for 5 minutes. We just finished unit 1. We're now going to be jumping into unit 2. We finally get to define what probability is and all of that fun stuff. So here is the deal, just so that you have it. Lesson 2 due tonight by midnight. Activity number 2, you got to have it emailed to me by tomorrow. Tomorrow we Zoom class. If you haven't turned in your activity number 2, if you hand it to me physically, I hand it back to you physically. If you email it to me, I don't print it out. So those of you who are here who have not gotten activity number 1 back, if you handed it in to me physically, I have it. So I'd love it if you take that. And then what I'm going to do is Zoom class tomorrow. Notice tomorrow we'll start lesson 4. And then on Friday, I will hand out our 3rd activity, which will allow you to gain some more practice. Sound good? All right. So I hope you all have a really awesome day. And I will see you virtually tomorrow. Thank you.